Hello, welcome back to FE Test Prep. Today we're going to be doing a statics problem as an example of our sum of the forces and sum of the moments equals zero. We already reviewed that key concept in the introductory video for statics, so this problem should serve as a key example for sum of the forces equals zero and sum of the moments equals zero. Let's take a look at it. We've got two boulders, two spheres that are pinned against a wall, 7.5 kilogram and a 10 kilogram. They're stuck together and they're stuck against the wall. These walls have zero friction. The frictional coefficient is zero. You've got an 80-degree slope here, 75-degree slope on the other side, and we're looking for the force at B. Now, how are we going to solve this? Well, we know that this is at rest, so some of the forces have to equal zero and some of the moments have to equal zero. So let's take a look. Obviously there is going to be forces at A and B, but we know from looking at this that there shouldn't be any moments just because the forces are all applied directly into the center of these circles. Okay, so first thing we'll do is draw a free body diagram. What I like to do for the free body diagram is simplify it. This one, we don't even need to think of them as two separate. We can just think of it as one giant rock that's wedged in between. So you can think about it like this. This is probably a bit too large. Let's narrow it down here. Right, so let's say it looks like this. We know we've got a force from B here and a force from A here. And each of these forces can be broken down into corresponding X and corresponding Y. So this is what we're going to look for. We're going to do sum of the forces in the X equals zero. So with our X direction, we've got, this is going to be equal to, right, it's going to be F force at B, right? So we have a force at B, but we need to figure out what component of that is our X. So this is a trick that I like to use, so I'm not worried about how the angles go. I just know that my force in the X direction, if I'm looking at B, so if this were actually 90 degrees, then I would have all my force in the X. I'd have no force in the Y. And so what component, cosine or sine, gives me 1 when that's at 90? And that's going to be our sine. Yeah. So this is going to be FB sine 75. And then we're going to say that's in the positive X. We're going to say this is in the negative X minus F of A. We'll say the same thing here, right? So it's going to be sine of 80. And this is our X. Then we have sum of the forces in the Y equals zero. Right, so right now we've got one equation, two unknowns. So obviously we're going to need to get another equation if we want to solve for that second unknown. Luckily, we've got the Y direction. Yeah, so in the Y direction we've got the weight. Forgot to put this on the free body diagram. Right, we've got the weight of the boulder. So, X direction, they're just balancing each other out. The Y direction, they're holding up the weight of the boulder. Because, right, there's no way the Y component of the weight could factor into the X's. So you just say these two will equal each other. And then for the Y equals zero, so this is going to equal, I'm going to put this down here. This is going to equal F, we're going to say positive, right? So FB cos 75 plus FA cos 80 minus, and this is the summation of these two, right? So we'll say 17.5 kilograms times 9.8 meters per second squared. Since that's a gravitational constant and we're doing force here. So these are our two equations. This is equation 1. This is equation 2. You got two equations, two unknowns. Now all we have to do is solve them. So one thing that we can do here is simplify this equation up top and sub it in here. So we can very easily say that since these two are equal to each other, let's solve for f of a in terms of f of b. So then we can sub that into this equation. So we'll say f of a is equal to fb times sine 75 over sine of 80, which is going to equal, whoops, this is actually 60 degrees. I misdrew this. And so f of a is going to equal 1.12 f of b. F of a equal 1.12 f of b. Then we're going to sub that into here and say 17.5 times 9.8 equals FB cos 75 plus 1.12 FB times cos 60 cos 60. And then when you solve for f of b here, f of b equals 209 newtons. So this is our answer right here for the statics problem involving the two boulders. You can see that we started with a free body diagram, so we wanted to draw out all of the forces. We simplified this. I just think it's easier to look at it in this way, just one boulder as opposed to two, since they're going to be held up similarly. And then we went and did sum of the forces in the x equals 0, sum of the forces in the y equals 0.